It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farmers Really Nice Coffee.
Hi guys, welcome to the fourth video for the organic chemistry section. This one is all about carbohydrates. So hopefully you worked out the reason why there's Homer holding a donut. Other than that, he's Homer and he's awesome. But donuts are obviously a source of carbohydrates, and carbohydrates come from food. So we're going to be in particular looking at just what makes up carbohydrates and some of the ways that we can just tell if something's going to be a carbohydrate, and then the three types of carbohydrates. So a carbohydrate is a naturally occurring sugar or its polymer form. So it's really important to know these three reasons down the bottom of how you tell if something is a carbohydrate or not. Okay, there's lots of carbohydrates. There's something called monosaccharides, or what we call simple sugars. There's disaccharides or disugars. Oligosaccharides have between 2 to 10 sugar molecules. We're not actually going to be looking at those in this topic, so I just wanted to show there is a section that's in there. We're going to be looking at monosaccharides, disaccharides, and also polysaccharides, which are polymers of monosaccharides or disaccharides. So you can see there's a number of different carbohydrates here, and what makes these carbohydrates is these three rules. They're either a polyhydroxyaldehyde. Now the word poly means many, and hydroxy is OH groups. Okay, so first of all, it has to have lots of OH groups. Okay, now you can have molecules that have lots of OH groups but aren't carbohydrates, and the reason for that is they're not an aldehyde or a ketone functional group in there. So you must have a molecule that's got lots of OH groups, and it must have an aldehyde or a ketone in there as well. Now, if it doesn't contain one of those, like the polysaccharides and the disaccharides, they don't generally tend to have aldehydes or ketones in there. So this is the third point. If you hydrolyze them, and hydrolyzing means add water in, if you can form a polyhydroxyaldehyde or ketone molecule, then that makes it a polysaccharide, sorry, a carbohydrate. So make sure you learn those three rules. Here's the first two I'm going to introduce you to. Glucose, I'm sure you know. I mean, we have the common name of sugar for this. Okay. Oh, look at that. You guys must be amazed at every video at my awesome stellar writing skills. They're pretty good, aren't they? So this is sugar and this is fructose. Okay, both of these are what we call monosaccharides. You can see them up here, and both of them have the formula C6H12O6. Okay, now what you can see in these ones is that same formula, different structure, so that makes them isomers. And the reason they're carbohydrates is you can see both of them have lots of OH groups in there. Okay, and in glucose, what we've got is on the end here we've got an aldehyde functional group, and in fructose we've got a ketone functional group here. So they're both polyhydroxy, either aldehyde or ketones. Right? They're just structural isomers of each other. So monosaccharides we sometimes call simple sugars, and again you can see glucose here and you can see fructose here. Galactose is the other one, okay, and galactose you'll quite often find in milk, all right, and you can see this is an aldehyde on the end as well, so that's a polyhydroxyaldehyde. The main difference between glucose and galactose, it doesn't look very different on this page, but you can see that we've got OH groups in different positions here, these red highlighted ones. And it doesn't seem like much, but that does actually have an impact upon the molecule and the way that it reacts with itself and reacts with other things, because you've got to remember these are three-dimensional structures. They're very soluble in water, which is what you'd expect because they've got a massive amount of OH groups. Okay, so there are lots of sites for hydrogen bonding, and they are also very high melting point solids. So you think of sugar or glucose exists as a solid at room temperature because you've got lots of hydrogen bonds holding the molecules together. They require lots of energy to break, and so it's a high melting point. And yes, that was iced coffee, as if I'd drink anything else. There are many different types. They have structural isomers. They are structural isomers, so different structure, the same chemical formula. So these are what we call the straight chain forms. We can also see them sometimes as what we call ring structure or chair structures. So here's sugar cubes, which is glucose. All right, it has that formula, exists as that straight chain which we saw over here, which has the aldehyde group in it. but it does also exist as this water-soluble ring structure. So what actually happens is that the oxygen over here actually bonds to a carbon atom. So I'm not sure if you can work out which one it actually bonds to, but what happens is we've got this section over here with an OH, H, so that's actually the end of the chain. Alright, so that's that CH2OH and this bit here. So we actually get a bonding over here, okay, between sort of this carbon down here, alright, and up to here. So we get a bonding happening down here to make our 5-membered ring structure. Now what you can see happens is that we actually lose our aldehyde group. Okay, so you can tell which structure of glucose you have by doing a Tollens test, which we covered in the last video for aldehydes and ketones. So if you use ammoniac with silver nitrate, the straight chain form, because it's got this aldehyde, will form a silver mirror, whereas the water-soluble ring structure doesn't. So when you dissolve glucose or sugar in water, you get this equilibrium between the chair structure, which is this one here, and the straight chain structure as well. And you can tell if there's straight chain in there by doing a Tollens test. Now disaccharides, if we put a di in front of something, that means 2. So disaccharides are formed when we do a condensation reaction between 2 simple sugars. Now remember, the definition for a condensation reaction is where you eliminate a small molecule. So in this case, we've actually eliminated a water molecule. I'll show you on the next slide because it's a little bit easier to see. Alright, so if you take glucose and fructose together, you get sucrose. Glucose and glucose gives you maltose. Glucose and galactose gives you lactose. Okay, all of the disaccharides have this formula of C12H22O11. Okay, so you can see if we've taken 2 lots of C6H12O6, okay, 2 lots of those should give us C12H24O12, and the difference between C12H24O12 and C12H22O11 is 2 hydrogens and 1 oxygen. So we've eliminated a water molecule out of it. Okay, so you can see on this one we've got the 2. These are the 2 from the previous slides here. Okay, so we've got galactose and glucose. Okay, so galactose and glucose coming together. We have these an OH from here and a hydrogen from here. So these 2 combine to eliminate out to form our water molecule, and we just link up to monomers here, or those simple sugars, by what's called an ether group. Alright, this oxygen here by itself, that's an ether. It's not one which I don't think they really need you to know anymore in Year 12 chemistry, but an ether group is a single oxygen which joins 2 carbon atoms, and so this is now a disaccharide. We've eliminated our water molecule. What they expect you to be able to do in Year 12 chemistry is to be able to do this. Okay, so you need to be able to, if you're given 2 monosaccharides, be able to draw the disaccharide that it comes from, or they could actually give you the disaccharide and ask you to go backwards with the hydrolysis to be able to draw in the 2 monosaccharides that you started with. So it's pretty straightforward to do that. Just simply break the oxygen down the middle, put an OH on either side, and you've remade your monosaccharides like we've got up here. Okay, suggest you just try and Google just some disaccharide structures and then just practice going through and trying to write the monosaccharides they come from. Now, polysaccharides are complex sugars. Okay, so these are long polymer chains. They're more than 10 monomers put together. If you remember from that first slide, there generally tend to be lots and lots and lots, so thousands of them. And they have this general formula of CXH2OY. So what that means is there's always double the number of hydrogens to oxygen. Okay, so they have that formula, but that doesn't mean that they're a polysaccharide. Remember, what they need to also do is when you hydrolyze these, they need to form polyhydroxyaldehydes or ketones. So just because you see something with this formula, don't automatically assume that it's a polysaccharide. Make sure when it's oxidized, so when it's hydrolyzed, so when you add water back in, you get a polyhydroxyaldehyde or ketone. So they're insoluble in water. So the reason for that, this one's cellulose. Okay, so this is what you find in paper, and this comes from trees. They're insoluble in water, although they have lots of hydroxyl groups. You can see one here, one here, one here, one here, another one here, another one here. So there's lots of OH groups within the even just the repeating unit. what you find is that the chain kind of wraps in on itself a bit like this. All right, and what happens is that all the polar OH groups end up pointing in towards the middle, and so the outside of it basically just has your hydrogens off the chain, and so it's non-polar on the outside. So there's not really many sites for water to bond to make it water soluble. Now what happens is that if you heat it, all right, the chain starts to unravel a little bit, and now the water can get access to those OH sites to be able to hydrogen bond. So heating cellulose or starch or any polysaccharide increases the solubility in water, but they're still reasonably insoluble because they're such a big structure with so many carbons and hydrogens in there. Alright, you can see if you've done the section on polymers in topic 4, alright, about how to identify a repeating unit. If you haven't done that, the easy way to do it is you just find somewhere in the chain and you put a line down, like we've done this here, and then you want to find the next part where it repeats. Alright, so we've got this is a carbon here with a hydrogen on it, and then we've got a carbon with a CH2OH. So we have a look here. There's a carbon. No, we don't have the hydrogen above it. We don't have the CH2OH. So we go to the next one. There's a carbon with a hydrogen, CH2OH. So that's where it repeats again. That's the first bit. So we put our square bracket in there. So that shows our repeating unit on our polysaccharide. Now what they'll expect you to be able to do in Year 12 chemistry is to be able to take a polysaccharide like this and identify the repeating unit, which we've done, and then the monomer from which it comes. So in this case it actually is a disaccharide that we've got. So all we've done is chopped off the ends of the chain and made them back into OH groups, a bit like we did with the disaccharide going to a monosaccharide. And the reason we can do that is because, remember, it's a condensation reaction. Or they might ask you to take a disaccharide or a monosaccharide and make a polymer chain from it like this, in which case you just got to eliminate the OH each time as you go along. So easy way to do it is just take out a OH here, take out a H here, okay, and then put the whole molecule next to itself, bond it up via this oxygen, and you've got your polymer chain happening. So again, what I suggest you do is Google some polysaccharides with their long chains and try identifying the functional group in there and working out what the monomer is that it comes from. Well, that's polysaccharides. Hopefully you've been able to follow it pretty clearly. Key thing is to be able to remember those 3 points on the first slide around what makes it a polysaccharide. It's either a polyhydroxyaldehyde or a polyhydroxy ketone, or it can be hydrolyzed to one of those. There's 3 types: monosaccharides, disaccharides and polysaccharides. Make sure you can draw the structures of the disaccharide from monosaccharides or a polysaccharide from monosaccharides or disaccharides, and vice versa. Alright, I hope you've found this pretty straightforward. As always, if you have any questions, just ask. Thanks, guys.